12.2 is about measures of central tendency. What we have listed right now are a majority of what we're going to go over in this section. The first one is the mean, which is the sum of all values divided by the total number of values. Median is just the middle value when you arrange your data values from smallest to largest, or ascending. And then we have mode, the most common value seen in your data value set. And we will further discuss each one of these as we go through the lecture. Our first measure of central tendency is called the mean. And the mean is found by adding all the data items together and divide by the number of values that we have. In this case here, we're going to use the symbol X bar as the mean. Now, X bar actually refers to what's called a sample mean. The other symbol that we see in our formula is this, called a summation. Summation refers to adding, so we will add all the x's, the summation of x, divide by the number of values that we have. An example would be finding the test average. If you want to find your test average, you will add all your test grades together, divide by the number of tests that we have. Again, the mean is equivalent to finding the average. This table shows the highest earning TV actors and actresses for the year 2010-2011. And the question for this problem is asking you to find the mean average or earnings for the top 10 actors there. So you can see over here at the bottom, we have X bar is equal to the summation of X divided by N. So I added all the earnings up for the actors and divided by 10, the number of actors we have. And they came up with 14.7. Now, you're not going to say your answer is 14.7. Remember, this is a monetary amount, so this is the mean earnings for $14.7 million. All right, the mean earnings of these actors are $14.7 million. If we wanted to go find the mean for the ladies, the actresses, we would say X bar is equal to, and just let me write all this out, we'll add up all of those earnings. And then once we add them all together, we have to divide once again by the number of actresses that we have. And again, the number, it will be 10. And when you find the mean here, you're going to get 9.5. Now remember, once again, this is not just 9.5. This is going to be $9.5 million. And that is the mean earnings for the top 10 actresses. In calculating the mean for a frequency distribution, we have just a little bit different approach on it. We're still going to call it X bar because it is the mean, and it's written on here as the summation of X. This means times F, all divided by N. So that numerator is X times F, the data value times its frequency. And once we do that for each data value, multiplying by the corresponding frequency, we add those all together. That's the summation part. Divided by N, N is the sum of all the frequencies. Let me write that up here. Sum of frequency. So you can take that frequency column and add it all together, and that'll be your N. For this example, a questionnaire was given to students in an introductory statistics class, and it had ratings for how stressed have you been in the last 2.5 weeks on a scale of 0 to 10. 0 being not at all stressed, and 10 being stressed as possible. So the report or the data is given below in this table, your frequency distribution. Stress ratings listed from 0 to 10 on that first column. Second column is frequencies, the number of people that responded to each rating. So this is the first of 2 pages. The next page will go a little further into finding the mean. Knowing that we're dealing with a frequency distribution table, we're going to take a look at the chart. X values are the stress ratings that we have from the previous page. So that is our X value. We have the frequency, the number of students that responded to each stress rating. And then the third column, we have X times F, the data value times its frequency. So what we're basically doing is taking that first 0 rating, multiplying it times 2, the frequency, and we're going to set it equal to the third column, which is 0. So the third column is creating x times f, and what we do from there is we add that third column all the way down, the summation of x times f, and we get 975. Recall that when we add the frequency column all together, we will get n as our denominator. So when we find x bar, we take 975 divided by 151 here, and our outcome is going to be 6.46. So what they're saying is, for that stress level ratings between 0 and 10, the mean rating is 6.46. Our second measure of central tendency is the median. The median refers to the middle number or approximates us to that middle value. So the first thing you want to do is arrange the data item from smallest to largest. Then you want to determine how many values do you have. Is it an odd count or is it an even count? If it is an odd count, then we will have the middle number will be the median. If it is an even count, you have to find the average of the two middle numbers, such as the mean of the two middle numbers or the average. If you want to find the position, in other words, when you place your numbers from smallest to largest, you have the first number, the second number, third number, and so on. If you want to know what the position is, you take n, which is the number of values you have, plus the 1 divided by 2. And this will tell you what placement to look at. For instance, if we happen to have an even count of 6 numbers, I would take 6 plus 1 divided by 2. This will give me 7/2 or 3.5. So as my numbers are listed from smallest to largest, I would look at the third number and the fourth number and find the average of those two numbers to give me my median. So these are two examples. It says find the median for each of the following group data. Again, for the median, we need to list the numbers from smallest to largest. So we'll do part A first. These numbers are now listed smallest to largest. And we're going to count how many numbers we have. We have 1, 2, 3, 4, 5 numbers. So we have 5 values, which is an odd count. So when it is an odd count, we have a nice middle number that we will call our median. So the number 90 is the middle number, and that would be our median. For part B, we took the second set of data values and we placed them again from smallest to largest. And in this case, when we count the numbers, we have an even count on here. So let's see, 1, 2, 3, 4, 5, 6, 10 numbers. So since you have 10 values, which is an even count, that means we have to find the two innermost numbers and find the average of those two. So once again, the two middle numbers are going to be 28 and 34. And we add those two together, divide by 2, and we come out with 31. So our median for the second data set is going to be 31. Find the median for the following group of data items. So again, for the median, we need to place these from smallest to largest. So it looks like we'll have 11, 12, 13, 13, 14, 15, 17, and 18. And let me count my values up here. I have 1, 2, 3, 4, 5, 6, 7, 8 values. Remember, we're trying to find the middle there. And so since we have 8 values, remember to find the position on here. It is 8 plus 1 divided by 2. It gives me 9/2 or 4.5. And you don't have to do it this way. You can kind of look at the data as a group and realize where the middle area would be. I normally draw a line right through the middle. In this case here, this 4.5, so that's telling you the number that is in the 4th position and the number that is in the 5th position. You will take the average of those two numbers. So in this case here, in the middle, 1, 2, 3, 4, there's your middle. So we have to find the average of these two values in the middle. So 13 plus 14 divided by 2. This will give you 27 divided by 2, or 13.5. Once again, this is called your median. This is our second measure of central tendency. Our third measure of central tendency is called the mode. And it says the mode is the data value that occurs most often in a data set. So it is the one that has the highest frequency. And it says if more than one data value has the highest frequency, then each of these data values is considered a mode. And if there is no data value that occurs most often, in other words, there's no repeating numbers, then the data value has no mode. These are examples of finding the mode. So the first data set A has 7, 2, 4, 7, 8, 10. For the mode, we're looking for the number that has the highest frequency. So in this case here, I see that a 7 is repeated. None of the other numbers are repeated, so the mode is 7, the number that occurs most often. For part B, we have 2, 1, 4, 5, 3. So there are no repeated or higher frequency numbers, so this is considered no mode. For the third option, you have 3, 3, 4, 5, 6, 6. So we have repeated 3s, a frequency of 2, and repeated 6s. So the modes are 3 and 6. They both are considered modes. And in this case here, since we have two modes listed, it's considered bimodal. This problem is asking us to find the mode given that you have 54, 33, 42, 34, 36, 36, 48. Once again, you go through all your numbers and you look for the one that occurs the most often. So it seems like to me the number that I see the most is the number 36. So the mode here would be number A, and we would place 36 as our answer. So for this problem, it says find the mode or modes for the data items in the given frequency distribution. Again, this is a frequency distribution. So we don't have all these numbers listed individually, but we could if we wanted to. It would just take a while. So in this case here, we have our score, which is the X value. And in the second row, we have our frequency, or F. So you have to find the mode. So when you're looking for the mode on a frequency distribution, you want to focus on the frequencies. Look for the highest value in the frequency. So when I look at the second row, the highest number I see is this 6 right here. So that's telling me the score of 3 is listed 6 times. Again, the score of 3 is listed 6 times. So it says select the correct choice below, and if necessary, fill out the answer box within your choice. So the mode is not the number 6. The 6 is the frequency. The mode is going to be the number 3. The number 3 is listed 6 times, so 3 is my mode. The fourth measure of central tendency is called the mid-range. The mid-range can be calculated by finding the lowest data value added to the highest data value, and then dividing by 2. Adding the lowest data value plus the highest value, then divide by 2. Straightforward and simple. This is called the mid-range. Let's look at a problem. Find the mid-range for the following data items. So when you take a look at these values, we're looking for the smallest and the highest value. In doing so, I find that 86 is my smallest number that I see, and 91 is the largest. So for the mid-range, I'm going to take the smallest number plus the highest number, 91, and divide it by 2. And this will give me 89. So 89 is my mid-range of this data value set. To see a better depiction of how the different measures of central tendency vary, let's take a look at this example. So it says, suppose your 6 exam grades in the course are 52, 69, 75, 86, 86, and 92. Compute your final course grade. All right, and they gave us the scales for A's, B, C, D, and F. We're finding the mean, median, mode, and mid-range. So part A, we're finding the mean, or X bar. Remember, for the mean, we add all our values together, divide by the number of tests we have, or grades is 6. So we end up with a mean of 76.67. In this case, that is a solid C. The next option is to find the median. The median, you list your numbers from smallest to largest. And in this case, since there's 6 grades, we have to go in and find the 2 innermost grades and take the average of those. So that would be 75 plus 86 divided by 2. In doing so, we find our grade to be an 80.5, which is a B. For the mode is the most frequent number. So when we take a look, the only number that happens to be, in this case, repeated is the number 86. So the mode on here is an 86. So it's saying your final grade would be an 86 or a much higher B. And then we have the mid-range. The mid-range takes into account the smallest value plus the largest value divided by 2. In doing this operation, we get 72 or a low C. So you can see the different variations of central tendencies depending on the outcome that you want. Of course, most students would like to get the B. So if you look at the median, it only took account into using 2 data values, the 75 and the 86, and it came out with a B. The mode is only looking at one number, the repeated 86. So those are not very good foundation for finding your average grade. Best way to do it is to find the mean. Take into account every data value divided by the number of values you have. So in this case, I would like to use the mean to calculate your final grade. For this problem, it's giving you a frequency polygon and it's saying use the display of data to find the mean, median, mode, and mid-range. So I rewrote this just a little bit so that we could see all the scores listed below and the frequency on the vertical axis. All right, so to find the mean, remember, since this is a frequency distribution, I wrote down the scores that are involved, the 10, 11, 12, 13, 14, 15. You can see the score of 9 has a height of 0, and the score of 16 also has a height of 0. So those are not included. If we had to draw a histogram, the 9 and the 16 would not be included in your histogram because there's no height or frequency of them. So for 10, we're looking at a height of 2. I'm going to place my 2 right here for my frequency. 11 has a height of 2. And 12 has a height of 5. 13 has a height of 6. 14 has a height of 2. Remember, I'm comparing this with my y-axis there. And 15 has a height of 1. So I'm going to write these corresponding frequencies down onto my table, my frequency distribution table. Well, that was a 5 right here. And a 6, a 2, and a 1. All right, so remember what we have to do is multiply every data value times its corresponding frequency. So that'll give me a 20 here, 22, 60, 78, 28, and 15. Next, we're going to go in and add up the frequency column, and we're going to add up the summation of x times f. All right, so the summation of x times f is going to give me 223. And when I add my frequency column, I am getting 18. So in this case here, to find our mean, our x bar, we're going to take 223 divided by 18, and that will give me 12.4. And this is my mean. All right, next we're going to go take a look at the median. And if you look at your scores between 10 and 15, you can see what the median would be. We can list all these out. So we have 18 numbers. Our total frequency is 18. And if you take 18, remember we're going to go in and add 1 and divide it by 2. That gives you 19 divided by 2, or 9.5. So we're looking for the number that is in the 9th and the 10th position. All right, so let's count these numbers out. So if you look at the frequencies, I'm going to add this 2. I'm looking at my frequency column on my distribution. 2 plus 2 is 4. 4 plus 5 is 9. So this value is telling me it's going to be between the 12th and the 13th is where I have to find my median. So my median is equal to 12 plus 13 divided by 2. 25 divided by 2, and that's going to give you 12.5. All right, that is my median. For the mode we're looking at the number that occurs the most often. So in this case, it's really easy. All we have to do is go to the highest peak on our polygon, and at frequency of 6 here, that's going to be the number 13. So the mode is 13, the highest frequency. Next, we're going to go find the mid-range. The mid-range is the lowest value plus the highest value. So the lowest value that we have is a 10, highest value is 15, and divide by 2. This is going to give you 12.5. 25 divided by 2, 12.5. So I'm just going to write these values up. For the mean, I have a 12.4. For my median, I had a 12.5. My mode is 13, and my mid-range was 12.5. For our final exercise, it says find the grade point average. Assume that the grade point values are 4.0 for an A, 3.0 for B, and so on. So a C is going to be worth 2 points, and 1 point for a D, and 0 points for an F. All right, those are called point values. So here are the grades that we have in our chart. We made 3 Bs and a C. Now each course has a different credit hour. So the B for the first B has 4 credit hours. The second B is worth 5 credit hours, and so forth, reading that down. So what we need to do first of all, I'm going to make this a little bigger. Let's go for grades here. B, 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 and a C. Credit hours. All right, and we have 4, 5, 5, and 3. Now remember, you want to put in the point values. So a B is worth 3 point values. So I'm going to put that 3 in right here. This B is worth 3, and this B is worth a 3. Earning a C is worth 2 on the point values. We're going to go in and multiply these items straight across. The point value times the credit hour. So when you do this, you're going to end up with 12, 15, 3 times 5 is 15 again, and 2 times 3 will give you 6. All right, and this column that you have now, these are going to be the earned point values. So these are the point values that you earned with those credit hours. So first of all, we need to find too, how do we know how many credit hours we took that semester? So we need to add up this column right here and calculate. So you take 4 plus 5 plus 5 plus 3, and we took 17 credit hours. Well, that's a pretty good load there. And then when you go in and add the number of point values you earned for that semester with those grades, you earned 48. So the grade point average, also what we call the GPA, grade point average, our GPA is going to be found by taking the sum of the earned point values, which is 48, divided by the number of credit hours that you took for the semester, 17. And it does say round to the nearest hundredth on here. So when you do your calculator work, let's say that 48 divided by 17, I'm getting 2.823, and rounding to the nearest hundredths is 2.82. All right, so having a GPA of 2.82 is basically a high C. It's not a B, even though we made all those B's in there. It is a 2.82, a high C. This concludes our lecture.